Hi guys, so we finished yet another phase of the whole course. Basically, we finished batch processing. So now, starting from today, I would like to talk a bit about streaming. And that's the topic for today, so let's get started. Alright, so let's talk about streaming scenarios, which differ completely from batch ones. But before we go, quick recap. So in case of batch processing, it was done in a way that we usually scheduled our processing to happen once, maybe twice a day, usually during the night, when the impact of our processing on some other systems would be minimal. And those batch processings worked in a way that they simply connected to some source data, grabbed all the data that was produced within the last day, then made some processing, and finally produced some output. So the next day when employees come to work, all those reports, all these data sets, or whatever you are creating, would be refreshed with the data that was calculated during the night. And this approach is a correct one. It works in many cases. But the drawback is that you never have live data because, well, if you recalculate it once a day during the night, then, well, you always see all the data. And there might be cases when business wants to see live data. At the same time, when something happened in the source, they want to see the result, the outcome on the reports without any delay. And that's a real-time processing. Basically, there is no delay between the time that event happened and the time it was handled by your solution and then probably shown on a report. And, well, just to give you some examples when streaming could be used. So let's start with some extreme case. Let's imagine that you are building an analytics system for a hospital in which there are multiple patients, some of which might have some heart issues. So they might have some heart sensors attached to them, which, well, they measure their hearts, right? If everything is fine. And if suddenly something bad is starting to happen, the heart rate is dropping, then the nurse or the doctor has to be notified immediately without any delay, just to help the patient, just to react. And if it was done using batch processing and this information would be presented next morning, then, well, it might be too late. So that's the case when the action has to happen immediately without any delay. And I know this was an extreme case, so let me give you some other examples from my life. So some time ago, I was buying an apartment and I made this really big online bank transfer. And within a minute, this nice lady from the bank called and asked if it was really me who was doing this transfer, because it was so big, it was so unusual compared to my regular activity. And basically, this was a way to detect fraud operations. So again, in those cases, a reaction has to happen immediately within a few seconds, few minutes after something happened. Some other examples might be with highway. Let's say that there is a highway and multiple cars are going through it. There is this toll gate when the payment is being made. And maybe someone would like to know how many cars are passing through the gate in real time. And again, that's a use case for streaming. Another use case might be, well, we've got a factory that is filled with various sensors, for example, that measure how hot is in the factory, how much humidity there is in the air. And again, if something bad or unusual is detected, for example, some equipment starts to overheat, then maybe this device should be shut down just to prevent some loss, some damage. And again, it has to happen without any delay. Some other use cases might be, well, you have an online shop and you run some promotion, so many customers are buying your product and you would like to see your sales in real time. Again, use case for streaming. Or maybe you have a website that is so popular that you want to analyze every click as it happens in real time without any delay. And again, those clicks, when users clicks on some item on your web page, it might be sent for analysis in real time. Again, use case for streaming. So basically, there are many use cases when this real-time processing or a near real-time processing has to happen. And streaming, well, it faces a lot of challenges that don't exist in case of batch processing, and we'll get back to them. Alright, so I told you about those various use cases, but I would like to show you something that works in action. So let's jump to Azure portal and to my application. So what I have here in the middle, is this real-time data simulator. It is a free application written by Kamil Nowinski. Yes, the same guy who created ADF tools. And this app can be used, well, to generate some events based on the configuration that you want to use. And that's what I did. I downloaded the source code of this application and I just executed this. So what I have here, so basically I can provide how my messages, my events will look like, because I want to generate those events. So later on I will be able to analyze them. And let's assume that I would like to simulate a situation when there are multiple students that are rating my courses in real time. And every time they rate my course, this event is generated. And that's the content that you can see on the screen. So we've got publish time, basically when this event was generated, and the score field, that is some random value between 1 and 10. And the nice thing about this tool created by Kamil is that, well, we have a lot of flexibility about the way we can configure it. There's a lot of things you can add to the payload, to the body of those messages. And as you can see, it will be just a JSON that will be later analyzed. So let's see how a sample message would look like. Like so, some publish time and some score, 7. Pretty good score, I would say. And then we've got to configure this application to tell it where to those events should be sent. And I just provided some details about Event Hub. We'll get back to this. And then some publisher settings. Simply how many events should be sent and how often. So in this case, I'm using a single thread that will send 100 batches, and each batch would send 20 messages. So in total, I would send 2000 messages, 2000 scores. And there will be a delay of 2 seconds between each batch. So that's my source of my data. Then I have some processing implemented using Azure stuff. And as a final part of the whole solution, I have this very simple dashboard created in Power BI that shows two things. So first of all, it will show average score as it is received from this simulator. And you will see that it will show this average score by 5 seconds. So what does it mean? Well, in the case of streaming, streams usually they don't have a start, they don't have an end date. They just happen continuously. And usually we don't want to aggregate or to analyze all the data. No, we want to split it into parts, and each of those parts is analyzed. And that's what I'm doing here in Power BI. So I'm splitting all the data that I'm receiving into 5-second windows, and within each of those windows, I'm calculating the average score. That will be displayed here as this line chart. Secondly, I have a second tile that shows how many messages we received within last 5-second window. So let's run this and see if it will really work. So let me start the simulator. That should start sending those messages, and in a second we should see that this Power BI stuff, it starts to show some data in a real time. That's what streaming is all about, just to react to events as they happen. So maybe I would like to analyze if you like this course or not, and we can see that indeed this diagram, this chart, is changing because it is displaying the data that is generated by the simulator. I know it's not super fancy scenario, but that's just one of the use cases that, which can help you to visualize how the streaming scenario might look like. All right, so let me stop generating those events and let's talk about how it could be implemented in Azure. So let's jump into whiteboard and let's start talking about streaming. So streaming, how the architecture might look like. And you'll see that actually those big parts of the whole architecture will be quite similar to what we had in case of batch processing. Of course, we'll use different tools, we'll have different challenges, but those phases will be more or less similar. All right, so how do we start? Well, we always have to have some source of data. In case of streaming, we usually call them event sources or event producers. So let's write this down. Event sources, or simply event producers. And well, here we can have a variety of various sources. We can have some applications. We can have some IoT devices, those various kind of sensors that are located in a factory. You might have smart house, smart home that is filled with various sensors, and maybe you would like to react if some movement is detected when there is no one in the house. So it might be a bad person trying to get into your house. We might have various type of streaming sources. So basically, well, just like in the case of batch processing, we've got some data sources. That's it. But the thing with streaming is that those event sources, those producers, they constantly produce data. And we've got to analyze them without any delay. All right. So great, we've got data sources, but somehow they have to, those events, they have to land into Azure. So what's the next phase that we have to do? Well, we've got to ingest all these events, all those messages. So we'll have this ingest phase, but we will not use Data Factory. No, Data Factory is not a good option for streaming scenarios. We'll have different services. Then, once the data is ingested, once it is available inside Azure, what we would like to do with the data is to, well, process it. And processing is a very wide term, depending on your requirements. For example, in my case, what I did with the example that I presented 5 minutes ago was to split these scores into 5 seconds windows and then calculate average value. But your case might be way more complex. But anyway, usually we want to process this data somehow. And we'll get back to this in the next episode. Then, once the data has been processed, well, we want to do something with it, right? Because what's the point of processing the data if it is not handled later by some system or by some person? So what we want to do finally is to serve this data, for example, to end user. And here we have various options, various ways we can serve the data. For example, we could use Power BI to show those real-time dashboards. But it's not the only way. We can just dump the data in a data lake, or we can store it in a database for some further processing. But we'll cover that separately. But basically, that's the architecture of our system. So let's try to analyze the ingest phase, the first one, how we can make sure that those events will be made available for further processing. And basically here in Azure for the ingest phase, we've got two options, two services that might be used. We have something called Event Hubs that I will focus on today because that's the main service that we'll use. Alternatively, there is a second service called IoT Hub. But I will not talk much about this one. Exam focuses on Event Hubs. So in both cases, well, those services are simply entry points to Azure. Those are the services to which event producers will send the data. So later on, some other services can plug in to those Event Hubs or IoT Hubs to process the data. Now, before we focus on the Event Hubs, let me tell you two sentences about IoT Hubs. So IoT Hub is meant to work with IoT devices. That's the main use case for them. And the interesting thing about IoT Hub is that it is bidirectional. So let me explain what I mean by this. Bidirectional. So let's say we've got some sensor in Azure, in a factory, that is measuring some temperature of some engine or whatever. And if we detect that the temperature is too high, we might want to send a message back to this device, please shut down the engine because something bad is happening. And IoT Hubs, they allow us to have this two-way communication from the IoT device to Azure and the other way around. In case of Event Hubs, it is only from event producers to Azure. So that's the big difference. But in both cases, Event Hubs and IoT Hub, it is simply an entry point to Azure. Now, if you would like to play around with IoT Hubs, then there is this nice IoT simulator that I will show you in a second. It's free stuff on a GitHub. So what you can see right now is this, well, let's call it simulator of Raspberry Pi. This stuff that has some sensor attached that measures temperature and humidity. And on the right hand side, well, you can see some source code of this stuff. Basically, it generates some dummy values of those two properties, and it is sending them to IoT Hub. So to make this work, to run this whole simulator, you just need to provide a connection string to your IoT Hub that I did already. And once it is done, let me just run this, and you will see that, well, it looks fancy. It gives this wow effect because we have this blinking diode, and on the right hand side you can see the messages that are generated by this simulator, and they are sent to my IoT Hub that I have provisioned in my Azure. And you can see here that, well, it is a JSON message. It has some message ID. It has some identifier of the device of this simulator that is sending the data. And we've got those two values that we'll be able to analyze later on, temperature and humidity. So if you would like to play around with this Raspberry Pi, that's the way to go. And link will be available in the video description. So let me stop this. And let's get back to Event Hub, because that's our main service that we'll use basically for streaming. So the rule of thumb is as follows. If you want to use streaming in Azure and it is not related to IoT devices, then most likely you will use Event Hubs for ingestion part. Alright, so let's see documentation about Event Hubs, especially the first sentence, because usually I encourage you to go to documentation and check the first paragraph about specific service, just to understand what is the high-level description of this service. And in case of Azure Event Hubs, it is like this. So Azure Event Hubs is a native data streaming service in the cloud that can stream millions of events per second with low latency from any source to any destination. We'll try to decipher this description. The thing is that, well, it is used for streaming. It has quite good scalability or performance, at least based on this description, and low latency, so it should be fast. And it can connect to any source and any destination, so it should be quite flexible. So let's see that in action. And what they also say is that, well, it is compatible with Apache Kafka. And if you did something with streaming in the past, you should be aware of Apache Kafka. That's this industry standard of handling streaming. So Event Hubs, well, they can communicate with Kafka, they can understand this. Which means that if you have any existing streaming solution that uses Apache Kafka, you could plug in Event Hubs, and they should work without any issues. Also, what is nice about Event Hubs is that, well, they integrate quite nicely with Stream Analytics and Databricks, and those two services can be used to process the data. So this part, we will not touch processing today, but just let me write this information down, that Stream Analytics and Databricks is supported. And it shouldn't be a surprise that Databricks can handle streaming because, well, we saw that already in case of Autoloader, which uses structured streaming under the hood. So basically, you should see that Databricks is very versatile. It can handle many types of workloads. That's why it became so popular. But we will not talk about Databricks today. Today, let's focus on Event Hubs. Alright, so actually let's try to create brand new Event Hubs in Azure, and we'll see what options we have. So let's move on to Azure portal. I have Event Hubs already in the lastly used services, so let's go there and let's create a new Event Hubs. And let's see what properties we'll have to fill. And by the way, take a note that here it is called create namespace. This Event Hubs namespace, not a specific event hub, but Event Hubs namespace. And in a second you will see what's the difference. Then, as always, we've got to indicate where this resource is to be created, in which subscription, which resource group. So let me go into DP203. Let's give this namespace a unique name. It has to be globally unique, I believe. So let me call it DP203 Event Hubs Table. It should be free. I want it to be located in West Europe, because that's where I live. And then we've got pricing tier. And take note that we've got something like called TU, PU. But what is this? We've got various tiers with those various units. So actually, let's browse those available plans and let's compare them to understand how those tiers differ and what Event Hubs can offer us. All right. So we have those three tiers: basic, standard, and premium. And here on the screen you can see differences between those plans. And the first thing you should see, well, is a consumer group. In basic tier we've got only one, in standard 20, and in premium 100. Great, but what is consumer group? So let's jump back to a whiteboard to draw some internals about Event Hubs. All right, so it looks as follows. So this black rectangle, this is our Event Hub that you want to provision. And Event Hub, well, it is used as this front door entry point to which event producers can send messages. So we can draw an arrow that events are coming this way. Then inside Event Hub, we have something called partitions. We can have between 1 and something partitions. Today I will not focus on explaining why partitions can be used. We'll do this in the next episode. For now, please just be aware that partitions exist. Partitions. And now, whenever an event is sent to Event Hub, it is inserted to some partition. So let's say that those blue lines are our events that are added to some partition. Great, but well, we want to do something with those events. We want to process them. So at the output part of the Event Hub, we want to consume those events from partitions. So outgoing arrow would be, well, simply to consume. Consume events. And this is where consumer groups appear. So basically, our downstream applications are called consumer groups. Consumer group. And documentation says as follows, that basically each downstream application that is plugged in to Event Hub, that reads data from Event Hub, is a consumer group. As simple as that. So getting back to this pricing tier, well, it means that in basic tier, we can have only one consumer, one application that is plugged to our event hubs. In standard, you can have 20 and so on. So that's the first difference between these two. Then we have a difference when it comes to number of connections that can be established to an event hub. We've got some cost, and then message retention that is set to 1 day for basic, but for 7 days in case of standard, and 3 months for premium. But again, what is this message retention? So it's like this. Whenever the event is sent to Event Hub and some consumer reads it, this event is not removed from the Event Hub. No, it stays there. So please be aware that the behavior is different than we saw in case of storage account queues. So it is not storage account queue. In case of queues, it was like this. Whenever some message was taken from the queue, it disappeared. Here, it is different. Here, we can read the same event multiple times, because those events, they are stored for some period. That is called retention period. So this setting, this retention period, it determines for how long our events would be stored in the Event Hub. Alright, but what's the point of storing those events for a day or for a week? Well, let's say that you have multiple consumers connected to the Event Hub, and each of them wants to read the same events. So it cannot work in a way that the first one wins. The first one who reads the event takes it. No, it has to stay there for every consumer that would like to read it. Secondly, maybe for some reason you would like to reprocess your events. Maybe you had a bug in your application. And to make this work, those events have to be available. So yes, they are there. So this retention period, it determines how long those events would be stored in the Event Hub before they are automatically removed. And depending on the pricing tier, this maximum period, it differs. So in basic, it is between 1 hour and 1 day. In standard, we can keep it for 1 week. And in premium, we can keep it for 3 months. Alright, and then we've got something interesting, which is called capture. That is, depending on the tier, it is either paid extra or included in the price. So what is this Event Hub capture? So again, in case of streaming, we usually focus on analyzing data here and now, as the data comes. But maybe you would like to use the same data, those events, to run some batch processing on a wider scope of data. So you would like to keep this data for a longer period than the message retention allows. Maybe you would like to dump them to data lake and analyze them in the same way as you do with any other data source. And capture is the feature that allows you to very easily configure your Event Hub to automatically dump the events to a storage account, to a data lake or blob storage. So how does it would look like? How it would work? So basically, if you configure capture, you would simply indicate, hey, I want all those events to be stored on a data lake or on a blob storage if you don't want to use data lake. And it is just a matter of enabling this feature. You don't have to create a specific processing that would save the data to a data lake. Obviously, it is possible. You can, if you want, create a process that would just grab all those events, maybe aggregate them, and save the aggregated data or even the raw ones to a data lake. But if you would like to do this automatically, very easily, then the capture is for you. And data would be obviously saved as files, and they can use any of those formats like Avro, Parquet, or Delta. And Delta is in preview, so might not work. But that's what capture is. It's a feature to automatically dump all your events to a data lake, so they could be stored basically forever, if that's what you want to do. All right, so let's choose, let's say, the standard tier, and obviously choosing a tier, it impacts the price. And we've got the price that is displayed here. It is set for, in euros in my case, per month, per TU, or PU in case of premium. But what is this TU? And well, TU is a throughput unit. It is a metric or unit of scalability in case of Event Hubs. So it is like this. We've got TU. TU, it is simply a throughput unit. Throughput unit. And it works in the following way. A single throughput unit, it allows you, it has some limits when it comes to ingress and egress. So ingress, and by the way, ingress is the incoming data, and data that is sent to your event hub. So basically, how many events you can send in a unit of time to Event Hub. And for a single throughput unit, it is like this. It is up to 1 megabyte per second or 1000 events per second, whichever comes first. In case of egress or egress, and again, egress is in this direction, how fast you can read the data from the Event Hub. And for egress, it's basically doubled ingress. So it is up to 2 megabytes per second. Or 4000 events per second. So based on your requirements, based on the number of data that you have to process, you should be able to choose a proper number of those throughput units. And you can see how much you would pay for a single throughput unit. So in my case, I would go with standard plan. That's fine for me. Or maybe basic would be even better because it's cheaper. All right, then, well, we have this slider to indicate how many throughput units we want to have. The more units, the more expensive the Event Hub will be, but the more throughput it would have. And now, what if you set this value to low? What if it will not be enough to process all of your data? Well, we've got this auto inflate option that if we enable this, it will allow us to automatically increase number of throughput units just to accommodate to increased workload. I will disable this in my case. So auto inflate works in the following way. So we've got auto inflate, and it allows us, well, to increase number of throughput units depending on our settings, to what limit we configure it. But please be aware that it works in one way only. It can only increase throughput units. It will not scale it down. No, you would have to do this manually. But at least we have this possibility. Alright, so I think that's everything that we have to set. So let's create this new Event Hubs namespace. And it should take a few seconds to create this. And once it is done, I'll be back. Alright, so my Event Hub namespace has been created. So let's go into it and see how it looks like. And now what is important here? So actually, one thing. What we just created is just a namespace, a container for Event Hubs. So here under entities, that's the place where we can create those Event Hubs that right now we have none. So actually, if we go back to our diagram, let me add this namespace to the picture. So actually it looks like this. This light blue box is Event Hub namespace. That's what we created so far. So Event Hubs namespace. And that's the logical container for our Event Hubs. But right now we don't have any Event Hubs yet. Those things to which we would like to send the data. So actually, let's create a new Event Hub. So I'm here in the Entities Event Hubs, and then I would click on the Event Hub option. And let me give it a name, like my first Event Hub. Let's indicate how many partitions I want to have. And by looking at the tooltip, you'll see that it has something to do with parallelism. We'll get back to this in the next episode. For now, let's just set it to 1. And here at the Event Hub level, we can set this retention time. And 1 hour is fine. Optionally, I can turn on capture, the capability of dumping those events to a data lake, to a storage account. But let's disable this. I don't want to use it. And finally, let's create our Event Hub. So that's the destination for our events. This is my first Event Hub. That's where applications would send their events to. Alright, but great. So let's go into this Event Hub. But how do we connect to the Event Hub? How do we make sure that only authorized applications can connect to them? And basically, well, we have 2 options. And I will talk about shared access policies. So we've got policies which simply mean what can be done by someone who has this connection string. So take a look. We've got 3 types of permissions or policies that we can use. We've got manage, that gives admin permissions to the Event Hub. We've got send permissions, that we've got to check if you would like to give someone permissions to send events to this Event Hub. And we've got listen permissions, that we've got to check if we want to give someone permissions to read the data from the Event Hub. And obviously you can select multiple if you want. So let's say that I would like to create a send policy only, like so. So what I did, I created a policy that gives permissions to send events to the Event Hub, to this instance. And to make it work with some event producer, what I would have to do would be to grab some connection string that has these credentials embedded in its body, and then simply use it in the application. And actually that's what I did. at the beginning of the session, here, this real-time data simulator by Kamil, it has this property where we've got to set one of those connection strings just to allow the application to be able to connect to proper event hub and be authorized to send data to it. All right, so, well, we can set policies. Shared access signatures policies. And we've got 3 options. We can set manage permissions. We can grant send permissions or listen. And obviously depending on the permissions that we set, they will apply either to possibility to send data to the event hub, or to read the data from it, or to just manage it. So depending on what we want to achieve. Secondly, we could use Entra authentication, but I will stick to those SAS policies because they are easier to set up. And then let's take a look at configuration properties. Is there anything special? No. So one more thing are those consumer groups. So one more time, consumer group is basically your downstream application, some application which connects to the event hub to read the data. And out of the box, we have this default consumer group that is created whenever we provision a new event hub. Obviously, we can create multiple consumer groups if we want, but I will stick to this default one. So actually, let me write it down that we've got this default consumer group. Now, one more thing about multiple consumers or consumers in general. To be able to resume work in case of any issues or whenever the application was paused, each of the consumers has to know which events from the event hub it already processed. And basically, each consumer has to store this information for every partition. Basically, what data it read already. And this position in the partition, it is simply called offset. And it is the consumer responsibility to save this data somewhere. And this persisting this data somewhere, it is simply called checkpointing. And again, that's something that you saw already in case of autoloader, because we had to provide this checkpoint path, this storage account directory where this checkpoint information would be stored. So in case of any issues or whenever autoloader was stopped and then restarted, it would know which data it already processed and which data it has to process. And the same is here. Now, fortunately, in case of stream analytics that we'll be using in the next episode, it handles this stuff automatically for you, so you don't have to bother about this. So that's how it works. All right, and I believe that's basically all that I wanted to cover today. So to quickly summarize, we started talking about streaming scenarios that differ a lot from batch processing, because here we've got a constant stream of messages, of events that we want to process in real time. And the first step in the whole process is to ingest data to Azure somehow. And the service that allows us to do, that we'll use a lot, is Azure Event Hubs. It's the place to which those event consumers would send their events. And later on, our event consumer groups, would connect to the event hub just to read the data and analyze it, process it somehow. But that's for the next episode. Alright, and that's it for today. Thanks for watching and see you next time. Take care.